Welcome to another video on industrial engineering. So in this module, we are going to discuss about quality control. And in this particular video, we are going to discuss an important topic of statistical quality control. So in order to understand statistical quality control, I will look at an example here. Suppose you are running a manufacturing company which manufactures steel rods. You have got an order to manufacture steel rod of 15 centimeter in size, and the customer is ready to accept a steel rod of 14.9 to 15.1 centimeter. Okay, so these are called the tolerance limit. Even if customer wants it at 15 centimeter, even if it exceeds up to 15.1 centimeter, he is ready to accept. So that is why this is the tolerance limit. And you are manufacturing it. You have got an order for maybe 1 lakh. Okay, and you manufactured it. Okay, but is this load acceptable by the customer? Okay, so these steel rods manufactured will have different length. It can be 15.01, 15.02. Okay, similarly 14.99, like that, because this is because the machine cannot be 100% accurate. There can be slight variation. But if you are manufacturing up to 15.2 centimeter steel rod, so this is not acceptable by the customer. So that means that leads to the rejection of your material, of your product. So if you have manufactured 1 lakh products, it is not possible to measure the length of each of these lots. Okay, so we can do only by taking a samples out of these lot. Okay, and then check for the length, right? So we are making use of statistics to control the quality or to measure the quality. So that is why this is called statistical quality control. Okay, now let us see the definition. It refers to the use of statistical methods in monitoring and maintaining of the quality of products and services. In our example, our product was a steel rod of length 15 centimeter. So it consists of two processes. That one is the process control. It means how to control the processing for quality. And then you have acceptance sampling. Here you are accepting or rejecting the products already produced. These are the two methods of statistical quality control. So statistical quality control is based on probabilistic theory. Okay, that means we are making use of statistics, which is again based on probability. So that means when you manufacture a product, it can be the correct size as required, or can be slightly larger, or can be slightly smaller, just like the example we have seen. We have seen a steel rod of 15 centimeter size. It can go up to 15.1, or it can be 14.9 also. It can go even below. In that case, it will be rejected. So what are these causes of variation? Why you are not getting the exact size? So it can be due to chance causes of variation. So these are minor variations in quality. So we have seen 15.01, 15.02. Okay, these are minor variations. These are not rejected because they are within the tolerance limit. Okay, our tolerance limit was 15.1 and 14.9. And it cannot be controlled or prevented. So these are non-assignable. You don't know the cause for this. It can be due to many factors, slight changes. Okay, so you cannot assign a particular cause for this. That's why these are called non-assignable causes of variation. The second cause of variation is the external causes and cause large variation. Okay, in this case, we need to reject, that is major variation, because of the major variations in quality. If the size is 15.3, so we need to reject that. And it can be due to the wear and tear of machine parts. So this can be controlled. Okay, you can control that, you can replace the machine parts. And it can be due to improper raw materials also. So this is another thing you can control. So these are assignable causes, you can find the cause for it. It can be prevented and controlled by detecting the causes, and you can rectify it. So these are the causes of variation. So now let us look at this chart. So let us look at our example once more. Our steel rod size was 15 centimeter, and the customers was ready to accept up to the limit 15.1 and 14.9. Okay, so these are the limits. So here the limits are 15.1, and here the limits are 14.9. Okay, and our target is 15 centimeter. Okay, so but the process, when you manufacture that 1 lakh product, okay, it will have different sizes. It will be 15, 15.01, 14.99, etc. It can vary, but how much it can vary? So the process as such, you have a mean that is called statistics. That means if you arrange the 1 lakh along a chart, 1 lakh products along a chart, it will be centered around mu, that is it can be 15 centimeter, and it spreads, you can see that. So it can even go up to, let us take for example, it can go up to maybe 15.15 and 14.85. So the process is producing products between 15.15 and 14.85, but the customer will only accept between 14.9 and 15.1. Okay, so this is the acceptable variation. But so that is why this is called the voice of the customer. Customer is ready to accept only between these limits. But the voice of the process produces goods up to 15.15 and 14.85. That means these are the defects that will be rejected. Okay, so that means the process is not under control. Okay, so this is how we use statistics to control the process quality. So statistical quality control can be used for acceptance sampling also. That means assumption. That means we are taking a sample and it represents the worn load from which it is drawn. We are assuming like that. For example, maybe we are producing 1 lakh products, and we take a sample of maybe some 50 out of which. So that is called sample. It represents the worn. We are assuming that this represents the worn load from which it is drawn. Randomly, samples are taken out and checked for defects. Okay, and these 50 samples, we are not checking all these 1 lakh product. We are checking only these 50 products. And if these 50 products are within our tolerance limits, then we will accept. Otherwise, we will reject the whole 1 lakh product. Okay. So this will have less cost of inspection, and it saves time also. So what are the advantages of statistical quality control? It helps in preventing defects and avoids the risk of accepting a bad load. And it saves money and time of inspection also. And it ensures high quality. Disadvantages, the rejected items, that means we are losing the rejected items. So there is a cost of production associated with that. We are losing that. Okay, in the next video, we will discuss about control charts used for process control.